Welcome everyone. My name is Pietro Asinari. I'm the scientific director of the Italian National Metrological Institute, INRiM. I'm very glad today to welcome all of you. I'm very proud also about this event, which is very important for us. I will also share with you a schedule about the meeting today, which is devoted to the World Metrology Day. So it's part of the celebration that we do as an institute for the World Metrology Day, even though we all know that the World Metrology Day will be May 20th, but we decided to keep the opportunity to merge this initiative with our regular seminar that we have on Monday. And that's the reason why we are taking this opportunity. I will briefly go through this program. The webinar is about measurements supporting the global food system. As you know, the topic of this year of the World Metrology Day is metrology for food. So definitely we try as much as possible to align this activity with the topic of the World Metrology Day. And I will just take 10 minutes or even less in the introduction for pointing out that definitely the metrology for food is one of the focal points of our institute. These focal points are formalized within the vision document that was prepared together with all the personnel of the institute by our president, Professor Diderik Wijma. He could not attend today the meeting, and so that's the reason why it's my pleasure to do this introduction for you. There are 6 focal points, and the quality of life, in particular, the activity of metrology with regards to food is one of them. So it's not by only the opportunity of the World Metrology Day that we will present you the ongoing activities of the Institute about this topic, but this is a topic we're working on by many years now, even with research infrastructure, brand new research infrastructure, collaborating with other research institutes, trying to give our contribution with a special focus on metrology for this sector. And then I'm very glad that today that we will have a very prestigious bunch of speakers that will develop this topic. And definitely I will also take advantage of the support of Chiara, in particular Chiara Portesi, who is co-organizing this event, and that I would like publicly to thank for her availability in doing so. So thank you very much. And I leave the floor to Chiara.
Thank you very much, Pietro, for your kind introduction. I will leave the floor now to our colleague, Andrea Mario Rossi, who is going to present the European Metrology Network on food safety and sustainability.
Today, I would like to present the European Metrology Network for Safe and Sustainable Food. This is under the umbrella the BIPM that this year is dedicated to measurement supporting the global food system. Let me show some slides regarding to the activity of the BIPM and the role of the NMI. The Bureau International de Poids Measure is an international organization is established under the Meter Convention in 1875, and with the member states face the measurement science and measurement standard. In particular, establish and maintain a proprietary reference standard for the use as the basis of the key international comparison. And moreover, the BIPM coordinated the worldwide measurement system, ensuring it gives the comparable and internationally accepted measurement results. In the BIPM, there is the committee dedicated to developing and improving the documentary and equivalence of national standards in the fields of chemistry and biology. The role of National Metrology Institute and Design Institute is to give the traceability to the 7 units of measurements, and in particular the role of NMI and the EYES is to maintain and also to develop a primary standard, and to unbroken chain through the secondary standard, working standard, to impact to verification authorities, accredited calibration laboratories, and calibration and testing laboratories. The BIPM is a worldwide organization, and worldwide is organized in 7 regional metrology organizations, and in particular for the Euromet is the European Association of National Metrology Institute, with the aim to coordinate and to share in metrological activities and service in Europe. In this context, to the support to the Euromet founding, has been created in 2022 September, the European Metrology Network for Safe and Sustainable Food. In particular, the aim of the object of this network is to promote an harmonized approach to the food measurements, reference material and standard, which will allow to National Metrology Institute and Design Institute across Europe to respond to stakeholders and regulation with the confidence and quality. In particular, we wanted to face is to improve the European food safety system along the entire food chain, what usually is used the word from farm to fork, and also to ensure the traceability to SI unit. We would like to have a strong impact to economic sustainability, particularly in the trade and competitiveness, and also to the food waste reduction, that is an important topic in these years. And also in social sustainability impact related of the food safety and animal welfare, and also to guarantee the food provenance. And the last and not least, to environmental sustainability, therefore to reduce the impact of the food production in the environment. To that, we will to underpin the harmonization and then the standardization. As an example, in this slide, we have the 2 pyramids. One is what already shown is referred to the pyramid of metrology pyramids, and on the other side there is another example of the organization as a pyramid for related to European organization for guarantee the food safety that is coordinated by DG Santé, under which the European Reference Laboratory and National Laboratory guarantee the safety and the quality of the food in the Europe. In this field, that the European Metrology Network on Food would like to create a collaborative way the exchange of knowledge among the metrological community, that the work that already done in the food system and the sustainability, with at the European level with the activities coordinated by DG Santé. At the same time, is also to receive from them the needs on which the metrology community can work. The European Metrology Network, as I mentioned previously, started in 2022, and today there are 15 NMI, ADI that are member, and they already signed a memorandum of understanding. The strategy that we put to organize the network is to create a strategic research agenda on which the current and future European trade for the food safety and sustainability. In particular, we dedicate our attention to identify the relevant stakeholder, receive from them input from their measurement needs, and summarize these needs, and to, in a collaborative way, to establish a collaboration to guarantee the metrological traceability to SI to the measurement to SI units. Moreover, we will cover also different fields related to food safety and the sustainability and the circular economy. That is another important topic that we would like to reduce the food waste and also to use the food waste in, for example, for an application in food packaging has to increase the shelf life of the food products. And then to the health and also to the nanotechnology, meaning the new technology and new material that can guarantee the quality of our food that reaches our table. Therefore, the strategy is to increase and improve the communication and exploitation plan, and moreover to align with already existing smart specialization to the national level, and engage the key stakeholder, and also to with the stakeholder to participate to European metrology program that funding the activities in the metrology fields, in particular in the food and systems. To do that, we have divided our activities in three main pillars. The first pillar is related to the metrological activity in support of the advanced analytical measurements. The other pillar is related to promote that already existing certified reference material, and moreover, with the input of stakeholder to work for the production of new certified reference material. The third pillar is related to give support in all the system for the sustainable food. Therefore, the engagement of stakeholder, the first one is to prioritize the stakeholder, and the second point is through the mechanism, for example, as the surveys to understand the requirement and prioritize the material and the metrology trainings that the member they needs. And then moreover is also to give support to the industry. Therefore, the stakeholder on the left side, you see the primary stakeholder that actually we put in our list, and moreover there are also the area of the impact. One of the primary is the legislation, given to the support to the legislator to the quality of the measurements, and therefore and also on the impact in all the food chain that are listed from the health, animal health and plant health. Just to give an example, in November 2022, we organized as a network in TÜBİTAK UME a training on measurement reliability on mycotoxin. In this case, was an hybrid event that attended more than 250 participants and 48 countries all around the world. Then is also we put an attention about the sustainability. At the moment is supported by a European project under the Euromet call, and but for the future we plan to have a funding for a different or existing European program, and also to cooperate with other existing infrastructure. Actually, there are other activities that we already started and project. In particular, in this slide, I showed just the principal activity and project that we are ongoing and we collaborate. One is related to the tracing the micro and nanoplastic in food and environment. This is a very important topic. The project is a plastic trace, and this project is important because the plastic and nanoplastic is a hot topic, and then the metrology community would like to give support to the standardization bodies to establish rules and regulation to identify the particle in food and environment metrics. Moreover, also the food contaminants like PFAS and mycotoxin in collaboration also with the European Reference Laboratory and with the national activities like INRiM, that is an infrastructure dedicated on the food packaging and sustainability. And moreover, we participate to the inter-laboratories comparison study and reference material and development. This is my last slide that we would like to create one voice for Europe to drive the metrology in the food safety and sustainable food. Thank you for your attention.
And now I will leave the floor to Claudia Zoani, who is the coordinator of METROFOOD, which is the metrological infrastructure for promoting metrology in the food area. Please, Claudia, the floor is yours.
Okay, thank you very much for the invitation. I'm very pleased to be here and participate today. I will introduce briefly about METROFOOD RI, which is the infrastructure, the research infrastructure for promoting metrology in the agri-food sector. From where we started, let's say, we started considering that so many challenges that the agri-food systems are facing or started to face in recent years, because our, let's say, adventure started more or less 10 years ago. And we followed time by time also the evolution of the agri-food system challenges with reference to whatever is related to food quality, safety, authenticity, traceability, sustainability, and transparency, as well as with reference to, for instance, sustainability and resilience of agri-food systems, which is a topic that raised to the attention mostly with the COVID-19 pandemic crisis, or with the Ukrainian war, and also taking into consideration the so many interconnections that are in place between agri-food systems with the environment, consumer aspects that are related to consumers' health, and so also the so many social and societal aspects that are relevant and related to the agri-food, and the increasing importance to apply and make practical the One Health approach, combining or considering in a unicum human health along with animal health and environmental health, and also the central role of the food production system in the agroecological transition. So there are several topics where we have to focus on, like, for instance, also according to the European Community and European Union indications and policies, etc., like, for instance, environmental safety, environmental impact of agri-food production, sustainable management of territories, but also the need to support the agroecological transition towards a sustainable and resilient agriculture, or to improve food safety, food quality, and the control of food production systems, the aspects that are related to the application of new technologies and their effect on food quality and safety and on human health, the importance to treat and to face side streams and byproducts, valorizing them, and reducing at the same time food losses and food surplus, and the need to improve, for instance, the transparency of agri-food productions, and to adopt healthier and more sustainable diets. Taken together, all these aspects are can be strongly supported by metrology. So we have to consider that, or we consider that metrology represents somehow the foundation, the basis for supporting food production and consumption in all its aspects, so to support at the end the food and health system and domain, representing also an engine towards research and development and towards innovation. So we have to consider that metrology can play a key role in supporting also all these challenges that the agri-food system are facing, for instance, by means of the development of new analytical methods or systems for early detection and in situ and inline measurements, but also with the increasing need to promote harmonization and standardization. And a very important role of metrology can be envisaged also in relation to the aspects that are related to the digitalization of agro-industrial systems and big data handling and the application of the FAIR approach, because let's say without metrology we cannot really apply or handle big data in a reliable and trustable way. So it's very, very important, and this is from where we started in thinking about the infrastructure, because in the meaning of ESFRI and the European Commission, research infrastructures can play a very important role in realizing a connected ecosystem, forming a unique resource for advanced research and interdisciplinary analysis of complex scientific problems. And in this sense, they have the capacity to provide resources and services for research community on a long-term basis. So our purpose was to do this exactly for supporting agri-food systems and to help them in facing all these challenges and aspects by means of the provision of services and putting at the disposal of the scientific community open data, facilities and structures in a view of a long-term sustainability of the infrastructure itself. So that's why let's say, METROFOOD RI born, and it's currently included in the ESFRI roadmap for the domain health and food, working for enhancing quality and reliability of measurement results exactly in support to the whole agri-food system, and by applying an approach that is related to the whole food chain and their interrelations. Currently, the consortium of the infrastructure is composed by 48 institutes from 18 countries that you see listed here, and it is under the coordination of Italy, where we have a very relevant, let's say, national node that is also currently supported by the National Recovery Plan, and INRiM is involved as well in the consortium. So we have a physical component of the infrastructure with several facilities that belongs to what we call it the metro area, where we have plants and laboratories for developing new reference materials, lots of analytical labs dealing with any aspect of characterization of the agri-food system, so not only food, but also, for instance, matrices that are related to the agro-ecosystem of production or food contact materials and so on. Then we have experimental fields, farms, and experimental plants for studying all the steps of food production and processing up to kitchen labs. And then we have a very important electronic component where to collect, integrate, share, and make interoperable all data that are produced by the physical infrastructure, but also interconnecting them with data that are produced by other initiatives and networks that are engaged in the agri-food system. So our research agenda has been defined taking into consideration the relevant policies and strategies from the European Commission, a very careful, let's say, landscape analysis also for integrating ourselves, METROFOOD RI, in the health and food domain for what concerns ESFRI, but also taking into consideration what it is relevant for the relapses or interconnections, let's say, cross-domain, and also for stressing the possibility of collaboration with other initiatives and networks, like, for instance, FoodMetNet, obviously, with which we are very complementary. And this is how we defined our research and innovation agenda for the next 5 years that you can consult freely online on our website. We completed in our timeline, let's say, your life cycle, the so-called preparatory phase. So at the beginning of this year, in January, we submitted to the European Commission the step 1 application for getting our own legal status of ERIC, and we are moving forward in the next steps of our life cycle, but always with the view or the plan to continue by providing metrology services in support to the agri-food, promoting excellent science, research and innovation, fully developing our facilities and integrating them in a plan that is devoted to research, training, technology transfer, and information and dissemination, also promoting the digitalization of the agri-food systems, open data and application of fair principles, working always in a way in which we can be fully integrated into the current landscape. And so for us, it's very important to have close collaboration and connection with other initiatives relevant in the field at national level of the national nodes that are involved in the infrastructure, at European level, and also globally. What is very important for us is the service provision and to give access to our facilities being open to the external users that in our case belong not only for the research area but can be also identified in policymakers, food inspection and control agencies, food businesses and consumers, and more widely citizens. So we have a service chart and the package offer, an offer of services addressed to the different kinds of users. And here I wanted to summarize some of the services that we already provided. Some of them are for virtual access and are, let's say, always provided free of charge and can be accessed by means of our website. But also I wanted to mention or to list 3 services that we are going to provide by launching open call that can be answered from any kind of user, of potential user. They will be fully open. They will be launched at the beginning of next year. And just let me say that for the one of focused on the characterization of nanoparticles in food and modeling instruments, the service provider will be INRiM. And some further, so this call will be launched in the frame of our Italian project, METROFOOD RI. Some of them will be launched very soon in the frame of the AgroServe project, which is an InfraServe project where 10 research infrastructures are working together to support the agroecological transition, and METROFOOD RI is also involved in. And there are some doubts because, okay, we expect to launch at least 3 further services in the frame of a new Horizon project that is still under evaluation, and we will use it for supporting these access free of charge, but I'm sure that they will open very soon because, okay, to fail is a word not included in our vocabulary, let's say. So I'm very confident that the services that we will provide next year will increase compared to this list. And what is very important, we will start also our living labs for sharing and integrating, co-creating with all the actors of the agri-food system. To conclude, just to inform you about a conference that will be held next June in Prague, where these new services that will be provided in the frame of AgroServe project will be presented, and also the conference will be an opportunity for discussing about transdisciplinary research services to accelerate the agroecological transition. I want to thank you all for your attention, and a special thanks to the whole METROFOOD RI family that is the most important part of our infrastructure.
Now I would like to leave the floor to Marta Dabrio Ramos from the Joint Research Center. She will focus her speech on the importance of certified reference material in food. Thank you, Marta. Please, the floor is yours.
And thank you for the organizers to inviting me to present the general importance of certified reference materials in food. Just let me start by a very basic statement, and is that food has a direct impact on human health. And as they say, we are what we eat. So as the regulatory bodies and governments overall are aware of this, they are making measures to protect the citizen. In Europe, we have a general food law that is covering general principles and requirements of the food law. And this is an overarching piece of legislation that covers many different aspects on food. They cover aspects like regulations on genetically modified organisms, on novel foods to be placed in the market, on authenticity, labeling, natural toxins and toxins in general, also on contaminants in food, which is the example I'm using in this slide. The general principle is a precautionary principle normally. It means that the levels that should be kept as low as reasonably can achieve by applying good practices, with the idea, of course, to avoid that products are placed in the market when they are not safe, so to protect the citizen. These legislations also, of course, foresee the setting of maximum levels of certain compounds or contaminants in this case. And again, I use an example of maximum residue levels for pesticides in food, where you have hundreds of different compounds which are having limit levels in a lot of different commodities, either vegetable or animal origin. But let me remark that I highlighted the word amount and levels in my slide, because whenever you set levels, then you need to control them. These threshold levels need to be controlled. These are normally done by official controls, by inspections or monitoring programs. And automatically this is linked to the laboratory work and methods applied in the laboratory and quantification of certain target compounds. The analytical results and the quality of the analytical results has consequences, or may have consequences, in the public health and or international trade, especially if the amounts are over or underestimated. So one case could be, I don't know, a set of oranges, a bag of oranges that are analyzed for pesticides, and if they are underestimated, the pesticides, that the batch of oranges could end up in the market putting some health risks. And if they are overestimated, that consequences could be economical loss, because some batches of things could be entering in the market or could be staying out of the market, and that would be the loss for the producer. So let's say the methods in the laboratories need to be fit for the purpose, and the results need to be highly trusted. And this is where the certified reference materials are coming into place, because they are internationally recognized standards, and they are very important to follow and to assure some trust. Formally speaking, a CRM by the International Vocabulary of Metrology is defined as a reference material that is characterized by a valid approach of some properties. It comes together with a certificate and provides certain values with an associated uncertainty and a statement of metrological traceability. This has been mentioned already by previous speakers. These are very important concepts. In practice, certified reference materials is used to help for method development, or to assess the accuracy of analytical method, just by establishing the method bias, or by calibration. Important here to mention that the same reference material should not be used or cannot be used for do simultaneous calibration and the method bias determination. But it is very important for the laboratory to do a CRM selection which suits really the needs of the laboratory and the purpose of the analysis. It has to be a combination of the proper matrix with the proper analytes or measurements and the proper levels of the measurements. This is a very basic scheme of process in a laboratory for analysis of pesticides in cucumber, where we choose a matrix CRM of a lyophilized cucumber that is contaminated with a certain number of pesticides which fit with our analysis. So the way to do determination, well, we can do a trueness check by analyzing the same sample together with the problem sample, following the same procedure, and then checking or comparing the experimental results together with the values that are stated in the certificate of the material. And then we can see if there is a bias or not in the method. This is also giving some traceability statement linked to the material itself so that we can have the chain traceability there. Alternatively or simultaneously, we can have a traceability statement via the use of pure substances on reference standards in solution. So overall, the CRMs are quality assurance tools that can be used in a punctual way, as I said, by determination of the accuracy of our method, or run over time in, for example, quality control charts to check regularly the quality of the results. CRMs are also serving for helping the standardization across the laboratories worldwide, meaning that the very same material can be measured in 2 different points or many different points of the globe, and they should provide, if the methods are correct, they should provide analogous results. And overall, at the GRC, we have the aim to support as much as possible the food legislation and other legislations, but now we are talking only about the food reference materials. This is a scheme of the reference materials production, which, okay, I'm not going in detail because for you in the end, what is interesting is the final result, the final product, which is the material, which comes together with the certificate with the values, etc. But also important to stress that this material is ensured to be an homogeneous one and stable under the conditions that we are setting in the certificate. We are, by the way, accredited for the production of certified reference materials. Now, about the type of materials that are produced and how this is decided, that's always a very complex issue because the need of certified reference materials overall is enormous. Everybody would like to have a reference material for their application, but that's not possible with the resources we have in place. What we try to do is to always communicate with other public reference materials producers to avoid as much as possible duplication, which means that we don't do duplication of a material. We can take another area or another material that is needed also in the scientific community, and we can take care of that. This is a slide which shows a little bit collaboration with other of our unit for reference materials production at the European Commission Joint Research Center. We, as I said, collaborate or communicate with other reference materials producers like NIST, BAM, LGC, ENEA, and collaborate with many organizations to define the new. So thank you so much for the organization and for your patience.
And now I will like to move to the presentation of Nives Ogrinc, Professor Nives Ogrinc from the Stefan Joseph Institute in Slovenia. and she will present the isotopic techniques for food analysis.
Thank you very much for this opportunity to present how isotopic techniques can be used in food science. And as you may know, the food fraud can detect or can affect 10% of the global food supply and costs the industry about 30 to 40 billion of US dollars every year. But it does not only harm our wallet, but also our health. And then, because of this, we need to find appropriate methods to fight against the food fraud, and stable isotopes opens new possibilities. But just before I'm going to show you how they can be used, just a brief background. And we all know that the isotopes are stable and unstable, and from the same element, they have the same number of protons, but they differ in number of neutrons. But they also differ in their abundances in the environment. And because of this, stable isotopic composition is defined in so-called data notation, where we have E as an element and then the R as a ratio between heavier and lighter isotopes, and we compare the ratio between samples and different standards. We have different standards for different isotopes of light elements. For example, for hydrogen and oxygen, we have Vienna standard mean ocean water. For carbon, we have Vienna PDB belemnite. This is the carbonate standard. For nitrogen, we have atmospheric nitrogen. And for sulfur, we have Vienna Canyon Diablo triolite, which is meteorite. And what is common to all of these standards is that their isotopic composition is defined to be 0. That means that any deviation of this standard shows you if your sample is enriched in heavier isotopes. That means that we will have more positive values, and in case that we will have more negative values, that means that our samples are enriched in lighter isotope. We are measuring the isotopic composition with isotope ratio mass spectrometer, which is schematically presented in this slide, with ion source, magnet, and detectors. But what is more important is that we need to introduce in such an isotope ratio mass spectrometer only pure gases, which are not always available in the environmental samples, also in food samples, and therefore we need different preparation systems to be connected to the isotope ratio mass spectrometer. And this depends, of course, of the type of the analysis that we want to perform. In case that we want to measure only elemental analysis, I would say bulk analysis, we can connect our system for elemental analysis and pyrolysis. But in case that we want to do compound-specific analysis, that means that we want to do measurements on the molecular level, then we need to connect the gas chromatograph to the isotope ratio mass spectrometer through the combustion unit. And because these measurements need to be very precise, because we need to find the differences that are significant at the fourth and the fifth decimal unit. So what information can we achieve using the isotopes? We can check if the samples are natural or synthetic. We can see if anything was added, or if it is adulterated or authentic. We can even find what kind of the production, it is organic or conventional, and even the type of the origin, that means from where the samples is coming from. But the steps are not so easy. That means we need to perform different steps in order to find the authenticity and traceability of the sample that we want to check. And for this, we need to develop standard operational procedure and then establish a database of authentic samples. And then we need to develop new statistical methods that can differentiate our samples according to the type, cultivar, geographical origin, and method of production. We can use linear discriminant analysis or the SIMCA, and lately we also use artificial intelligence. And the data bank of authentic sample is very important, and this is also crucial step in food authenticity and traceability, because we want to check if our samples are in compliance with the authentic samples. However, a good database needs good measurement data, and those proper metrological tools need to be applied. Besides sampling and standard reference methods, we need to use appropriate reference materials following the principle of identical treatment. That means in case that we want to measure honey, that means that also reference materials should be honey. Then we need to estimate measurement uncertainty, and it is also important to participate in interlaboratory comparisons and proficiency testing. So why are important the reference materials, especially for stable isotope labs? Because all isotopes labs must be able to measure the same sample and obtain the same delta value within analytical uncertainty. And the measured isotopic data with high precision and low accuracy need to be normalized. And usually we use 2-point normalization, and we need to use 2 reference materials so that with covering different covering different isotopic composition. You can see here we have 2 different points with heavier isotopic composition. That means that the first one is enriched in heavier carbon, and the lowest values is enriched in lower carbon, and it seems, and our data need to fall in between these 2 pairs of the reference materials, which is usually not always possible. And therefore, we develop new reference materials for food with the University of Indiana, covering different isotopic values and different commodities. We developed reference materials of honey, olive oil, millet, peanut oil, and also rice. And you can see we properly prepared our reference materials. We avoid the oxygen, and they are stored in the cold places. A very efficient way how to preserve small aliquots of the liquid reference materials, such as water, can be seen in this figure up with the aluminum silver tubes. And all these reference materials were then evaluated. That means the interlaboratory comparisons was performed and statistical evaluation. And now these reference materials are available as a USGS reference materials and can be provided to every laboratory who wants to get it. The next step in the isotopic analysis is the evaluation of measurement uncertainty, which can arise in every calculation step from raw instrumental data ongoing. And why is this important? Especially when we want to see if our data are in compliance with the reference data. We define the lower and the upper limit, and you can see from 4 different cases that in case A and B, our samples are in compliance with the reference database, while the sample or case D is not in compliance. But in case of C, you can see that because although the data, average data, fell out of the upper and lower limit or the range of our data, authentic data, the measurement uncertainty fell inside, and that means that we can say that these samples are in compliance with the reference database. We can evaluate measurement uncertainty with different approaches, like a Crichton spreadsheet approach, but any other approach can be also used. Another way how to prepare the uncertainty or to evaluate the uncertainty is the comparison or participating in the interlaboratory comparisons. And for stable isotope, we have the FIT-PTS. There are several different matrices detected for food analysis. It is organized 3 rounds per year with 6 different samples, food samples. We also participate in the CCQM organized by Isotope Ratio Working Group, where the difference between the FIT-PTS and the CCQM is that here only the designated institutes can participate, and none of the partners use the same approach in terms of the calculation sequence and data treatment. And all data need to have the measurement uncertainty and need to provide the budget. But because isotope community is very small, we also perform some stable isotope analysis and intercomparisons within different associations like firms. And by the evaluation of results, we can see that that almost all of the participants, or I would say all the participants seem very good results. And based on evaluation, we can still see that reference materials is still the main issue when we are doing the uncertainty budget. And we also perform the recommendations for isotope community, which were published last year in the EU PAC technical report. And these are important steps that need to be accomplished or need to be supported in the papers. So that means that we need to provide the analytical techniques, details on sample preparation, type and modes of instruments, metrological traceability, that means which reference materials were used, names, their values, and also associated uncertainties. Then data handling, how the measurements results were normalized, which kind of stable isotope data or scale was used. Either it was used 1-point normalization, 2-point normalization, or multi-point normalization, and also the uncertain evaluation need to be performed. So with this, I would like to thank all my group, all the projects, and you for your attention.
Now I leave the floor to Petru Jitaru from Anses in France. He will give an interesting talk about total diet studies, a powerful tool to assess the global exposure to inorganic contaminants.
I'm Petru Jitaru, coming from France, from the French Agency for Food, Environmental and Occupational Health and Safety, and I'm the head of the unit Trace Metals and Minerals, which belongs to the Laboratory for Food Safety. So I'm going to speak today very quickly about total diet studies, which are a powerful tool to assess the global exposure to inorganic chemical contaminants. Of course, not only inorganic, but this is my expertise field. So as Marta mentioned before, in Europe, we have what we call a food law, which is in force since 2002. And if you check this law, you will see that it relies on two main pillars. One pillar is actually referring to the routine analysis for food quality assessment, which generally applies to food trading. That means routine analysis, which are carried out by routine laboratories in each member state. And the second main pillar is what we call the risk analysis or the risk assessment, which is the ultimate tool for accurate and comprehensive risk assessment related to chemicals in foodstuff. And of course, today I will say a few words about the total diet studies. So, first of all, I would like to show you what is the difference between hazard and the risk, because sometimes there is confusion between these two terms. So a hazard is a potential source of harm. For instance, the presence of a shark in a sea is a hazard, while the risk is the likelihood that a hazard will occur and that will result in a harm. So, for instance, swimming in the proximity of a shark in the sea is, of course, a risk. So it's more or less the same when we speak about food contamination. The risk actually relies on two main parameters: the food ingestion, of course, but also the quantity. The food ingestion also in direct relation with the content of the chemical contaminant, but also the amount of the food that is ingested. So these two parameters, in fact, control the risk ultimately. So total diet studies are, as I said previously, are very good, and I would say even the ultimate tool to assess the food safety at the scale of a population. And the purpose of a total diet study is to measure the quantity of chemical substances ingested by the general population or by various specific populations like a region or population depending on the age and so on. And I would like to highlight that the total dye studies reflect the chronic dietary exposure or intake, and which is the methodology of such very large-scale studies. So these studies rely on a large and representative proportion of the diet of a global or specific population. Generally, we take into account at least 90% of the representative diet of a population. And what is also interesting is that the foods are prepared as consumed. That means we were supposed to analyze, for instance, pizza, sandwiches, soups, and so on, which are prepared in a special laboratory. We don't buy these foods as consumed directly from the markets, but we prepare in controlled conditions and so on. So this is totally different than the first pilot that I showed before, related to the food quality assessment, where generally we analyze raw food that is traded in some way. So the samples of the same type are generally pooled before analysis, effectively to reflect the global population. And what is important, of course, from meteorological point of view, is that highly sensitive and robust analytical methods are required for this kind of studies, mainly to limit or to have a minimum amount of what we call sensor data. And the sensor data are generally the data which are, or the results which are lower than the limit of quantification. Because if we have results lower than limit of quantification, we have a big doubt. So we have a big uncertainty, and it's very complicated to draw a conclusion. So here you see very briefly what happens, or how we carried out a risk assessment. Actually, there are two main ways. First, we have to characterize the hazard by chemical analysis, of course, all type of chemical analysis, inorganic or organic contaminants. And in this part, the uncertainty is quite reasonable because generally we use very trusty methods. But as I said, we have to use a second parameter, which is the exposure assessment. Actually, we need to know how much of a certain type of food is consumed by the population or by a special category of the population in order to calculate what we call the daily exposure. And of course, the information related to the amount of a certain type of food that is consumed by a certain population is quite difficult to obtain. So there is a very large uncertainty source in this case. So generally, starting from or using these two types of information, we calculate what we call daily exposure of an individual to a certain contaminant, which is generally expressed by microgram of contaminant per kilogram body weight per day or per week or even per year. This is not so important. And you see here the formula relying on the sum of the product between the daily consumption, the level of the food contaminant, and this product is divided by the body weight. And we have a sum because we can have different sources of exposure for the same contaminant. So if we want really to make a global picture of a certain contaminant, we have to sum all the sources, all the potential contamination sources. So here you see the list of the total dye studies carried out in France so far. So we are in some way quite happy to have been carried out 3 total dye studies. The first 2 total dye studies referred to adult population. The first one was carried out or at least initiated more than 20 years ago. The second one was completed in 2011, so more than 10 years ago. And the last one was what we call infant total dye study, which focused on children less than 3 years. I'm not going to go into all these details, but you see that we produced a lot of analytical results. In the first case, we produced 40,000 analytical results. The second study, 250,000 analytical results, 200,000 analytical results in the total dye in the infant French total dye study. For the moment, the third total dye study is ongoing, so we don't know exactly how many results will produce. But what is interesting to see is that the number of analytical results decreased steadily because we realized that it's not really necessary to go too much into details because there is already a kind of trend that can be established. So here you see how the conclusions of such a total dye study look like, and I took as example the infant total dye study, the last one. And you see really a capture of the report, which is in French, but I can translate it into English. You see that the risk is referred to 3 types of categories. So the very worrying risk, so is the column in red, a risk which cannot be excluded, a negligible risk, but also there is a 4th column where we cannot get a conclusion. So we don't know if there is a real risk or not. There is a problem either from toxicological point of view, that means we don't have enough information about the toxicology of the contaminants, or we had a problem in the analytical side. So if we focus only on the trace elements, you see that when in case of the infant total die study, there was a real risk, a real assessed risk related to lead, inorganic arsenic, and nickel, but the risk cannot be excluded for aluminum, methyl mercury, strontium, chromium-6, selenium for children more than 1 year, cobalt, barium, cadmium, and copper. And there was no risk, or the risk was negligible for chromium-3, inorganic mercury, and antimony. And we had problems to conclude in case of germanium, selenium, silver, organic arsenic, tin, gallium, tellurium, and vanadium. I'm not going to enter too much into details, but there are other conclusions in the same report dealing with the analytical side, because for some quite important contaminants like inorganic arsenic, nickel, and chromium-6, the analytical results were not of very high quality, because we had quite many sensor results or sensor data. So there is a very important recommendation to improve the analytical methods for the next total die study, which is the 3rd ongoing, and we did so. So what is new for the 3rd French total die study, which is ongoing? As I said, we are participating to this study with in terms of inorganic contaminants. I'm not going to speak about the total level, which is in some way the routine side of this kind of analysis, but for the first time, we consider the speciation analysis for a total die study, and in this context, we consider the speciation analysis of mercury, so methyl mercury and inorganic mercury, of chromium, chromium-3 and chromium-6, and arsenic, focusing on inorganic arsenic. So the 2 species, arsenic 3 and arsenic 5, and for that we got luckily the funds to carry out a PhD project that is entitled Development and Application of New Approaches for Speciation Analysis of Mercury, Chromium, and Arsenic in Foods, and Risk Assessment within the framework of the 3rd Total Diet Study. Of course, we have already all these methods available in the lab, but but these methods were not really adapted for a total die study, because we have a very large panel of different type of samples. As you see, only for speciation analysis we have 600 samples to analyze, and for total element determination we have around 1,000 samples. So we had to improve and to adapt all these 3 methods for the specificity of the total die studies. So one last idea in this context, the speciation analysis of chromium-3 and chromium-6 is going to be carried out by using species-specific isotope dilution in combination with HPLC-IC-PMS, and as you know, this is a primary analysis method with the highest metrological qualities. So in conclusion, what we learned from our French total die studies so far, so the first 3 total die studies, 2 dealing with adult population and 1 with infants less than 3 years. So the total die studies show that in certain population groups, there is a risk of toxicological thresholds being exceeded for some inorganic substances such as lead, cadmium, and inorganic arsenic, which requires effort to reduce exposure. I took as examples only inorganic contaminants because this was the topic of this presentation. And the total die studies have also shown that there is a need to develop scientific knowledge concerning both toxicology, but also analytical techniques for a number of regulated or non-regulated substances for which the risk assessment is currently not conclusive. So I finished my talk. Thanks for your attention. Unfortunately, as far as I understood, there is no time to take questions. So I would be glad to answer your questions by email or when we meet next time. Thank you.
And now we can move to the next presentation, which will be given by Mojca Milavec from Nives Institute in Slovenia. And the talk will be about nucleic acid analysis for food analysis.
So thank you for this nice introduction, and thank you for inviting me to be today with you on this event and to present the work from our institute. And I will talk a little bit more about bioanalysis, not so much chemistry. So we will look at the nucleic acid analysis and how the methods can support food safety and security. The topic of the talk will be plant pests, plant pathogenic organisms, so organisms that can cause different diseases in plants. And there are different organisms, of course, bacteria, phytoplasmas, viruses, fungi, and so on. In principle, when we want to deal with these organisms, the control should be in place, and usually plant diagnostics could be based on classical microbiological methods, but these methods can be time-consuming, and they are also not appropriate for all organisms and for viruses. So in these cases, nucleic acid analysis-based methods can find their way, and they are faster in comparison to classical microbiological methods and could be also more specific. There are some specific demands in this type of diagnostics. It is based on qualitative results. So usually the just presence or absence of microorganism or virus is important. And in addition, often there is zero tolerance for the presence of plant pests. So these methods should also be very sensitive, and they demand really low LOD. This could be dealt with if we would have reference methods and certified reference materials in this field, but unfortunately these materials are lacking in this field. To explain a little bit more, I have selected one example, and this is bacterial blight of olive caused by bacteria Xylella fastidiosa. This bacteria has been detected in or isolated from more than 300 plant species worldwide. So this means that these organisms are present in our environment all around us, but some of them can also infect crops, and in this case, this can decrease food safety and security. So not all of these 300 plant species are really, they don't all show symptoms of the disease, but some of them, some crops have serious symptoms, and this disease can spread really quickly. So this Xylella fastidiosa, this bacteria is currently one of the 20 quarantine pests, which are on the list of the priority pests established under the plant health law in European Union. And it is also subject of European Commission emergency measures. At the moment, this bacteria was not yet detected in Slovenia, but in Italy, you have really unfortunate example how this bacteria can cause really great damage in a region of Puglia. So there were the disease was spread there, and they had to destroy a lot of old, nice olive trees. The specific of this bacteria is that it is really slow growing, and classical microbiological methods are not appropriate because it takes too much time before we can take any action. So in this case, nucleic acid analysis-based methods were employed, and they are used in routine diagnostics. However, for nucleic acid analysis-based methods, we have to extract DNA or RNA nucleic acid from the tissue, from plant in this case, prior any analysis. And these extraction methods could be quite different. They can have different yields. They can produce different quality of DNA. So our interest was to see how different extraction methods can work with different plant species for detection of Xylella fastidiosa. So we have prepared different materials. These were bacterial suspensions of different isolates. This means that bacteria was isolated from different plant species from different positive samples. And also we have different subspecies of these bacteria. So we have prepared different bacterial suspension, and we tried to evaluate them with different methods. For example, McFarland method, which measures turbidity, and this is kind of indirect measurement of cell concentration. Then we did colony forming units. We just put different concentrations of bacteria on different media for cultivation, and then tried to count how many bacteria would grow on these plates. And similar approach was with different, so we just with spiral plater, we put colonies on this media, again, different type of media, and then we use the method, specific method for counting these bacteria. And in addition, we measured concentration of bacteria with digital PCR, so molecular methods based on nucleic acid analysis. That was preparation of bacterial species, and then we also selected relevant plant species. I told you that this bacteria is infecting different species, and we selected some of relevant species, taking also into account previous experience, because we knew that there are some more challenging matrices for extraction of DNA. So we selected grapevine, for example, and combined this with Xylella fastidiosa, subspecies fastidiosa, and then olive trees, which are major host of this bacteria, and rosemary, and we combined this with Xylella fastidiosa, subspecies pauca, and then myrtle leaf milkwort, which was combined with Xylella fastidiosa, subspecies multiplex. We have prepared plant extracts and then spiked 2 different concentrations of bacterial suspension in these extracts. Then we tried 4 different extraction protocols. This was done on 3 different days and in 3 parallels, so altogether about 300 concentrations, 300 extractions, and this was done, as I mentioned, in 2 different concentrations. And analysis of these experiments was done with digital PCR, but also qPCR approach, which is accredited and used in our laboratory for routine testing. And I just want to show you briefly some results. This, for example, is digital PCR results for pure bacterial suspension. This was measured in high concentration. You can see blue dots, which are positive reactions, and then gray dots, which are negative reactions. And from already from this just graphs, you can see that, for example, quick pick method might be more successful in extraction compared to, for example, Mericon method. But if we look at spiked materials, so now we have plant materials with spiked bacteria, and we did all these extractions, you can see that maybe quick pick, which was quite nicely presented in pure bacterial culture, here has a little bit more background and might not be so successful in final determination of concentration of bacteria. We can also see, if you look at the different plant species, that Olea is problematic matrix. It's more challenging because the concentration of bacteria extracted from this matrix was lower compared to the other matrices. And this is then the sum of the results. We can see from this graph even more obviously that if we take the same amount of bacteria in olive tree, and it was the same bacteria, the same subspecies was used also in rosemary, you can see that there is quite obvious difference between success of these extractions. And you can also see that some of the extractions give really high variability in results. So this can tell us that we should really take care when we are extracting materials, bacteria from different materials. To conclude, we have shown that quantity and quality of extracted nucleic acids is dependent on extraction method, and that methods that we select can have really significant impact on the performance of downstream methods, so on nucleic acid amplification-based methods. The problem with diagnostics would then be that laboratories have selected extraction method that they would like to use for different matrices, but in reality, this method cannot be appropriate, may not be appropriate for all relevant matrices. Using dPCR, we have shown really that the performance of these extraction methods should be evaluated, and this way we could see that we could achieve better comparability of results. And this digital PCR approach might be used as a reference method in further studies. And this is all. This was done within a nationally found project, ProRef. And here I would like to thank all my colleagues working in this project, and I would like to thank you for your attention.
Now I will leave the floor to Eli Fiener from TÜBİTAK UME. She will give a presentation about mycotoxin measurement in food matrices.
I'm Eli Fiener, and I'm working as a researcher at TÜBİTAK Marmara Research Center. And today I will talk about the mycotoxin measurement in food matrices. Here is a list about my outlines that I will talk about today. Mycotoxins, as you know, the secondary metabolites that can produced by the mycotoxigenic fungi such as Aspergillus, Penicillium, and Fusarium. The amount of mycotoxigenic fungi in the final product varies depending on the climate factors and food processing conditions. For instance, unstable situations such as temperature, moisture, pH, and nutrient content of the matrix are determining factor for the mycotoxin production. Detection of the mycotoxins, which have been proven negatively affect on human and animal health, it is a very important issue that needs to be controlled in the terms of ensuring the food safety. Here you are able to see the most common mycotoxins chemical structure, as well as the as well as the matrix of the product that they include inside. If we look at the aflatoxin B1, can found in the wheat, barley, and corn. For fumonisin, corn and corn product derivative can be contaminated with mycotoxigenic fungi. Before the start of the mycotoxin analysis, the sampling is important. To have a meaningful evaluation of mycotoxin contamination level, you need to have strategies of the sampling. Your strategies should have identification of the sites and the time that the lots are to be sampled. As you know, mycotoxins are fairly common in the field, sheep, silo, and processing step. And you need to identify, you need to determine your time, when will you take the sample from for examine. All in all, protocol to ensure that the test sample are representative of the lots from which it was taken. Why is the sampling is important? Just an example, I put it here. Think about the silos and you have 15 tons inside. Then you will take just 10 to 30 kilogram sample. Then you will send to a laboratory approximately 25 and 50 grams sample. Then the result obtained. The result obtained here, it will give you a contamination level. So the right sampling from top to the last, it's very important for your decision. Analytical methods for mycotoxin in feed and foodstuff generally require 3 steps. The first one is the mycotoxin extraction from the matrice with an adequate extraction solvent. The second step is the cleanup step, intended to eliminate interference from the extract. This step is important about decrease the matrix effect. The third one is the determination of the toxin by the suitable analytical instrument and technologies. What are these technologies? The first one is the ELISA. ELISA tests have been used for more than decades. The technology is based on the ability of the specific antibody to distinguish the three-dimensional structure of the specific mycotoxins. Currently, commercially, test kits produce results quickly. The assay can produce precise and repeatable findings, even though reducing the incubation time may result in a slight reduction of the test sensitivity. In addition, enzyme multiplied immunotechniques and fluorescent polarization immunoassay methods is used for mycotoxin analysis too. The second one is the rapid test. Fluorometry, strip test, card test, and the biosensor can be counted under the rapid test. There are new studies to ensure that the developed rapid tests are used in the production step, in warehouses, and even in the field, and it tries to obtain toxin-free food and feed. Here you can see the TLC mechanism. TLC is a simple, cost-effective technique often used in a mycotoxin screening assay when the low detection limits are not required. Here I can say we have here two phases. The stationary phase. Stationary phase material can be a silica gel, a cellulose, and their derivatives like a starch, polyamide. And for mobile phase, you can choose the acetone, methanol, or hexane. This technique is widely employed laboratory for mycotoxin analysis in the world, but not as much as in the past. Gas chromatography. Inert gases are using here for mobile phase: hydrogen, nitrogen, and helium. The stationary phase can be a liquid or solid. So there are two types of gas chromatography: gas solid chromatography and gas liquid chromatography. If we think about mycotoxin analysis, by combining the mass spectrometer to GC, mycotoxin measurement analysis can be carried out. However, because the other systems are more useful, GCMS is not recommended option for mycotoxin analysis. High performance liquid chromatography. As you see here in the picture, mobile phase is liquid. The solvent you can pick acetonitrile, methanol, ethanol, or their mixture. The stationary phase consists of very small to solid particles. The fillers of the column can be silicon dioxide, aluminum oxide, porous polymer, or ion exchange resins. The most important point in detection is knowing which mycotoxin can be searched with which detectors. I mean, aflatoxin include aflatoxin M1 and OTA can be detected under the fluorescence. Or UV or DAT detector should be used in the analysis of trichotescence. LC-MS is widely used for mycotoxin, especially multi-mycotoxin analysis. In the LC-MS approach, the sample molecules are examined with the mass detector after being separated by the UPLC apparatus based on their physicochemical characteristics. Matrix effect is one of the important problems here. The way they avoid this is to prepare matrix standard or work with a toxin matrix combination. So it provides a large reduction in analysis workforce and a large increase in analytical yield compared to conventional methods. Analysis of mycotoxin continues to advance scientifically with the development of new instrumentation. The link of HPLC, GC, and LC to MS had opened a new chapter in mycotoxin analysis. When we look at the LC-MS instrumentation, the use of generic sample preparation produced based on the catchers is nowadays well implemented in routine analysis of multiple mycotoxins. Judging for from the literature is likely that within the next decade, the market will consist of the test kits that are handheld digital biosensor capable of performing multiplex analysis. And thank you for your attention.
Now it's time to move to the next speaker, which is Dr. Vasilij Valenčič. He will from the ZRS KOPER Institute in Slovenia, and he will give a presentation about the analysis of edible olive oils.
So we start also with the olive oil and the fraud notification. As you can see in the 2021 annual report, the fats and oils ranked the third place in this fraud notification, and in 2020 were at the first, and mainly olive oil were the oils that were on this food alert. In the field of olive oil, we have a very good legislation that was improved in 2022, when the first regulation that was established in 1991 was repealed by two Commission regulation, the delegated and the implementing regulation. In the first one were described the categories of olive oils and the limits values for each category, for each parameter, and the labeling requirements. For olive oil, the implementing regulation are set up the methods of analysis, and now the references on the method are linked to the method of the International Olive Oil Councils. The implementing regulation also has the information regarding the conformity checks of the declared category and the flowcharts, and also for the work of the testing panel for organoleptic characteristics. So here are presented the quality parameters and the purity parameters that are very effective to detect the presence of other oil and of fraud with olive oil. So the flow charts and the decision trees are also a very good tool to detect if are present some refined oils, some extraneous oils, or presence of olive pomace oils, or other esterified oils, or oils with high palmitic acid presence. And so it is very important that these methods are performed with adequate personnel and well-trained personnel. On this slide, I would like to point out the development of the decision tree to another type of oil, the pumpkin seed oil, that is present in Slovenia and in Austria. And these are the results of the PhD studies of my colleague, Dr. Bojan Butinar, that studied the characteristic of these oils and was able to develop a decision tree approach based on the fatty acid composition, the trans fatty acid isomers, delta 5 to delta 7 sterol ratio, tocopherol composition, and stereospecific analysis of triglycerols. And also the analyses are suited to discriminate between cold pressed unroasted pumpkin seed oil and roasted pumpkin seed oil, and also to detect adulteration. For other type of oils, non-olive oils, in international marketing is present the Codex standards. Two main standards are related to vegetable oils, in which are described only the essential quality and composition factor. Other more complex compositional factors are named in appendix, which are not mandatory. And in comparison with olive oil, they don't cite or don't mention stigmastadiens that are a very useful tool to detect the presence of refined oils. In Slovenia, we have our legislation that describe that quality and compositional factors are mandatory, and all factors, not only the essentials. and the stigmastadien's maximum limit is prescribed in cold-pressed vegetable oils that must be below 0.15 milligram per kilos. Other countries have their own legislation, but usually the international standards are used to determine the quality of other type of oils. What about stigmastadiens? Stigmastadiens are steroidal hydrocarbons and are not present in cold-pressed vegetable oils, and they are derived from beta-cytosterols during refining processes. 3 methods are available for determination of stigmastadiens in vegetable oils. The first of the Olive Council, and 2 ISO methods with gas chromatography or HPLC. And all the methods are suited to detect the presence of refined vegetable oils in virgin olive oils and other oils. Here are the data of our studies, analysis for official inspection controls. In the last practically 20 years, 472 samples were analyzed. And you can see with the red color the compliance of the samples, with the red color the non-compliance, and with the yellow color are assigned the samples that at the time of the analysis were compliance, but with the new limit value that is in force from 2014 will not be compliance. So every year is some non-compliance from this point of view. We analyze also other oils for stigmastadien content on our Slovene market. As we see, the cold pressed pumpkin and sunflower oils were okay. We have a little bit of macadamia oil, 1 sample only, but we don't know if it was cold pressed, if it was refined, and which shows a higher amount of stigmastadien. For the coconut fat, we see that most of the cold press were okay. 1 refined has naturally a higher concentration of stigmastadien, and 1 cold pressed coconut has was non-confirmant because the amount of stigmastadien was too high. So what about rapid tests that are very popular and are very useful for routine analysis, that are based on FT-near spectrometry? And for routine analysis of vegetable oils and other food are very spread. The rapid tests are faster than other official methods without or with simple sample preparation, and also the equipment is very easy to operate. The measurement is fast, and the results, or maybe the prediction of the results, is based on calibration model. We have a prediction of what can be the results, so it is very important the calibration, how it's set. So as we can see in this example for palmitic acid, with the red color we have the fatty acid composition, maybe the amount of palmitic acid performed with accredited method with gas chromatography. With orange color is the manufacturer's calibration, which gives us different result from GC method. And then we have a new calibration that was constructed in-house based on the accredited method used. And we see that are still some variation, but the results are more or less equal to that of the gas chromatography. Of course, for palmitic acid is not any problem, because the lower limit value and the upper limit value are far away from the result. But in certain cases, these methods have some limitations. Also, only because a method is fast, it's not. It must be also accurate, and it's important of the interpretation of the prediction of the results. So we need for this method also well-trained and qualified personnel with knowledge and experiences. And for the last slide, the Oleum project was a big project when olive oil quality and authenticity was studied, when new methods and improved analytical methods were developed. There were a lot of scientific publication, more than 20 articles. Some of them were part from our institute. We worked on biophenols, volatile compounds, sterols, ethyl esters, and sensory analysis, and was a great job, internationally founded. And for conclusion, I would like to highlight the importance of traceability of the edible oils from the fruits, the seeds, and the production processes, because it's very important to perform a proper investigation of the characteristics of the oils, the use of validated and accredited methods, the creation of relevant calibration model for rapid test and traceability to standardized method, the application of known method to new matrices, and the data collection and discrimination between samples. And also the development of decision trees, and of course the investigation with alternative methods, but the traceability is still important. And thank you for your attention from the Institute of for Agriculture and our team.
Now we go to the last speaker of the webinar. I'm leaving the floor to Cristina Lamberti from CNR-ISPA. She will give a presentation about measuring food allergens.
I'm going to talk to you about measuring food allergens. Just start with a short presentation about food allergy. First of all, 90% of allergic reactions are due to a small group of foods named Big 8 that you can see in the pictures. And the first time that a potential allergenic patient meets food, apparently nothing happens, but actually after gastric digestion of allergens present in food, the peptide derived for gastric digestion can meet a lot of type of cells, dendritic cell, T cells, B cells, in order to produce a specific IgE, specific antibody that can bound the surface of the mast cells. So the second time that the patient meet the same foods, the peptide derived for gastric digestion can bound the IgE on the surface of mast cell, causing mast cell degranulation and production of a release of molecules involved in inflammation, such as histamines, cytokines, and so on. So what are our allergens? How look like? They are normally proteins from 10 to 80 kilodalton. Most of them are water soluble with multiple IgE binding site. And their peculiarity is that they are resistant to heat processing and also enzymatic digestion compared to other proteins. Why we test the presence of allergen in food? Mainly for guarantee consumer safety, to verify accuracy of food labeling, and to check cleaning effectiveness. For instance, if an industry produce and at the same facilities food containing and not containing allergenic ingredients. Which are the characteristics of our allergen quantification method? It has to be flexible because we need to measure solid and liquid, to analyze solid and liquid food and raw and processed food. It has to be specific, accurate, repeatable, sensitive, because we need to achieve a very low limit of detection and quantification, because even traces of allergens are dangerous for allergenic patient, and it needs to be validated or at least eligible for validation. There are mainly three principles at the base of this method. They can be immunochemicals method like lateral flow or ELISA. They can be DNA-based method such as PCR or mass spectrometry method. And moving from lateral flow to LC-MS method, we improve the complexity, the operator skills, and the cost of the method, while moving in the opposite side, we improve the routine use. The first method I want to show you is lateral flow. Everyone knows for their use during COVID pandemics. They are based on the binding between antibody and allergen. They are often used for in situ analysis. They are mainly qualitative, so they can check presence or absence of the allergen. They are very fast. They take less than 5 minutes. But they have a quite high limit of detection, and they often need confirmation technique. The second method is PCR method. We have, I can show you pictures of the step of the method. The first step is DNA extraction. Then there is the second step, then is amplification of DNA. And for this reason, we have lower sensitive compared to other method. This is good. And then there is detection. These kind of methods are suitable for processed food because DNA is stable at high temperature, but the main limitation is that they are not able to distinguish between different food products derived from the same organism. So, for instance, they are not able to distinguish between milk and bovine meat, or egg and chicken meat. This is a problem because, as you can see before, milk and egg are belong to the big 8, while meat allergy is quite unusual. So from a allergological point of view, this is a problem. The third method is the most used method, is ELISA, that has high specificity, and it is enough sensitive for current legal threshold. The main limitation is that there are few kits available for processed food because they mainly use the same extraction buffer, extraction procedure for any type of food, while very often for complex food or processed food, you should set up a proper method. The last method I show you is LC-MS. This is the most promising method for this application. So to quantify allergen in food, we can use multiple reaction monitoring technique that give you the possibility to follow more than one allergen for each allergenic food and more than one food at the same time. We can achieve with this method very low limit of detection and quantification. We are around ppb, and we have the possibility to use market internal standard, and it also suitable for processed food. This approach is characterized by 2 steps. The first one is a most theoretical step in which you have to choose for allergens characterized for the food that you are investigated, and then you have to perform in silico digestion of proteins in order to make a list of peptides that you have to follow by your analysis. Then you can move in step 2 in the lab to set up the protein extraction protocol, and then the proper LC-MS analysis that is characterized by a first step of triptych digestion of the protein mixture in order to have the peptide mixture and to separate this mixture by UPLC. Then you have the proper MS analysis. You have to choose which peptide you want to follow, of course, based on their ability to ionize in your experimental condition. And then you can link the full mass spectra of each precursor ions to the MS spectra of the product ions. These are for sure the method that is most improvable from, especially from metrological point of view. The peptide is the measurand in this case, and you can use the labeled peptide as internal standard to develop the isotope dilution MS method. Here I want to show you this publication that is the reference paper for absolute quantification of food allergen with the metrological approach applied to mass spectrometry. In conclusion, all these methods that I show you have advantages and disadvantages. For instance, lateral flow is a very fast method and for sure the less expensive, while ELISA has a high specificity and for this reason is the most used method, and LC-MS is the most sensitive and for sure most promising, especially from a metrological point of view. Thank you for your attention.
Thank you very much. And before closing the event, I would like just to remind you that this webinar was organized in the framework of the World Metrology Day 2023, measurement supporting the global food system. It was a joint event organized by INRiM and by the European Metrology Network on Food Safety and Sustainability. So I would like to first of all thank you, Professor Pietro Asinari, our scientific director, and Dr. Andrea Mario Rossi, who is the acting chair of the network. And then overall, I would like to thank you all the speakers that, thanks to their outstanding presentation, have covered some of the most hot topic in the area of food safety and sustainability.